So let's continue by showing you the following part of the demonstration where we have all the data set and data generated that we have collected from that environment that I just showed you. So here we conducted the further in exploratory data analytics, analysis, preprocessing, and all those machine learning process that we came up with designing a model, and we use different algorithms, and each of those algorithms shows different results. And as you may see, we are utilizing the Google Colaboratory as an online environment for conducting different EDA analytics and machine learning process. So we started with the process of data processing within the data science life cycle. We know that this step takes pretty much time to prepare the whole data set and all things before you would get into the analysis of the actual and data that exists and building and designing a machine learning model and conducting a train and testing with different algorithms. So we done all those pre-processing steps within the process, and we conducted some exploratory data analysis within the data set that we made together. And we have it two different scenarios as we demonstrated: the normal operation and the scenario where under the attack. Some cyber attacks were conducted toward the environment of the Wsn Smart Transport Network. So you will be seeing different results we have conducted through this analytics. And then we moved to the machine learning. We tried to look more on the feature engineering, and we selected some features that we think has much more impactful on the data itself and the model that will be trained and tested. So we re-engineered the features, and we came up by conducting a feature importance analysis to see if those features that we have selected would be enough and would be a key component within our process of designing machine learning. And further on, we focused on using different algorithms within the machine learning and to see their behavior on our data set. So we used the random forest and logistic regression as the two first algorithms, and we train and test that within our data set where we have it all the scenarios that we have done, normal one and those under attack. So we came up with a result which was represented further of the research publication in details for that. And after that, we tried to see more by tuning, by using different techniques within those algorithms or of random forest and logistic regression. We were trying to use the SMART class weighting to see what would be different results, what would be the behavior. We were just testing and seeing the results and comparison of all those results. And we got some results which was slightly different from those that we run it before. And further, we conducted a train and evaluation of machine learning by using the XGBoost and gradient boosting algorithms. Those two algorithms, for our case, has much better behavior for our data set that we have captured and collected from our virtual environment of wireless sensor networks of smart transport network. And we got the train and test of all those information, all those data sets that we used for this machine learning by those algorithms. And also at the end, we wanted to save our models on the extension of PKL because we further would build a web application, a web interface. We would build the whole application for our models. So the end user, the industry, would be able to access this web application from our hosting environment that we will provide, and they would be able to upload their data set and have predictions and evaluation by our model data set, which was built on top by using our data set we have generated from the demonstration. And we got the results, and those results were very good ones comparing to the two previous ones, random forest and logistic regression. And we came up to the end that we have included those results as the best ones, the two modules. So we have at the end the module in a PKL extension where we would use this module further to provide this as a service for the industry potential customers or clients using this kind of service. And we have some visualizations that we came through, which was needed to generate for our needs for writing the publication and submitting that to the journal. And also we have a model performance comparison where we would see that the last two algorithms of machine learning has a much better behavior based on our data set that we have trained and tested. We have also other visualization that were used for different needs, and we used feature importance for each algorithms that we have used. We wanted to see more on deep and to see what would be the behavior that was done by those algorithms. Here is shown a web application, web interface that we built for our model, our machine learning model that we use for the wireless sensor networks for the smart transportation. So through our model, we wanted to predict traffic attack based on the data set that we have trained and test those modules. And the best one was those two that we used, the latest one, which is XGBoost and gradient boosting. So this is all this web interface was built within the Python scripting language and by using the HTML for the good looking of it. So practically, you would be able to upload the data set that would be used for further prediction of your data set for the potential attacks that you might be having. So you, first of all, you might upload the data set, and then you would select the model that which model you wanted to evaluate and try to predict the traffic attack for the Wsn, wireless sensor network, of the smart transportation network. So this would be focused for this industry sector. So this would be the endpoint of our model on the web, how this would be looked. And what's left, you would select the model and then you would hit predict to see the prediction. Since we are on the testing, still on testing of this environment, we were experiencing some advancement and enhancement, so we would adjust more and have more ready on for to release it within the public. Thank you.